The series of enjoying great books we have today. We're continuing the series of Asimov's New Guide to Science by Isaac Asimov, and we are in the first chapter. The first chapter is a first, actually, second chapter is the universe. The universe. And the heading is the size of the universe, under which the subheading, we have already done the introduction. The first subheading is early measurements in the universe. The earlier introduction you can read in the earlier videos, and you can see the earlier videos, two videos. Early measurements. Chapter 2, the universe, the size of the universe, under which we have early measurements. The first scientific measurement of any cosmic distance came about 240 BC. Eratosthenes of Cyrene, Cyrene, the head of the library at Alexandria, 240 BC. Then the most advanced scientific institution in the world pondered the fact that on 21st June, when the noonday sun was exactly overhead at the city of Syene, Syene, in Egypt, it was not quite at the zenith at noon in Alexandria, 500 miles north of Syene. Exactly overhead, no shadow. But in Alexandria, it was not exactly overhead. Wow. Eratosthenes decided that the explanation must be that the surface of the earth curved away from the sun. Curved away from the sun. From the length of the shadow. In Alexandria at noon, on the solstice, from the length of the shadow on Alexandria at noon in the solstice, straightforward geometry could yield the amount by which the Earth's surface curved. So here we have two places, right? Sign, and Alexandria. In Sign, there is no shadow. In Alexandria at that time, there is a shadow. By that, how much shadow that is, we can know the curve, and then we can make it total, and we can get the circumference. That's a simple point there. From the length of the shadow in Alexandria at noon on the solstice, straightforward geometry could yield the amount by which the Earth's surface curved in the 500-mile distance from Syene to Alexandria. So from Syene to Alexandria, 500 miles, so much angle. So for 360-degree angle, how much? From that, one could calculate the circumference and the diameter of the Earth, assuming it to be spherical in shape, a fact Greek astronomers of the day were ready to accept. Eratosthenes worked out the answer in Greek units, and as nearly as we can judge, imagine, wonder, his figures in our units came out at exactly about 8,000 miles for the diameter and 25,000 miles, 8,000 miles for the diameter, and 25,000 miles for the circumference of the earth. So it will take 25,000 miles. If you want to travel the whole circumference, 25,000 miles only. These figures, as it happens, are just about right. Unfortunately, this accurate value for the size of the Earth did not prevail historically. About 100 BC, another Greek astronomer, Posidonius of Epamia, repeated Eratosthenes' work but reached the conclusion that the Earth was but 18,000 miles in circumference, not 25,000 miles. But 20,000 miles was more accurate. There was some mistake. It was the smaller figure that was accepted throughout ancient and medieval times. Columbus accepted the smaller figure and thought that a 3,000-mile westward voyage would take him to Asia. Had he known the Earth's true size, he might not have ventured. It was not until 1521 to 23 when Magellan's fleet, or rather the one remaining ship of the fleet, finally circumnavigated the Earth. Finally circumnavigated the Earth. That Eratosthenes' correct value was finally established. In terms of the Earth's diameter, in terms of the Earth's diameter, Hipparchus of Nicaea, about 150 BC, worked out the distance to the moon in terms of the Earth's diameter. Hipparchus of Nicaea, about 150 BC, worked out the distance to the moon. He used a method that had been suggested a century earlier by Aristarchus of Samos, the most daring of all Greek astronomers. The Greeks had already surmised, realized that eclipses of the moon were caused by the earth coming between the sun and the moon. Moon was eclipse that comes, it happens because sun and the um, moon, the earth comes between the sun and the moon. Aristarchus saw that the curve of the Earth's shadow as it crossed the moon should indicate the relative sizes of the Earth and the moon. On this basis, geometric methods offered a way to calculate how far distant the moon was in terms of the distance of the Earth. So first they calculated the by the shadows, straightforward. Indirectly, see, there is a simple detective work, and then they calculate the curve when it's crossing. The relative sizes, relative. Hipparchus, repeating this work, calculated that the moon's distance from the Earth was 30 times. Moon's distance from the Earth was 30 times the Earth's diameter. 30 times. The first diameter is this 1, 2, 3, 4, 5, 6, 30. If Eratosthenes' figure of 8,000 miles for the Earth's diameter was correct, if Eratosthenes' figure of 8,000 miles for the Earth's diameter is correct, the moon must be 2,40,000 miles from the Earth. The figure again happens to be about correct. But finding the moon's distance was as far as Greek astronomy managed to carry the problem of the size of the universe. Chapter size of the universe. At least correctly. Aristarchus had made a heroic attempt to determine the distance to the sun. The geometric method he used was absolutely correct in theory, but it involved measuring such small differences in angles that without the use of modern instruments, he was unable to get a good value. He decided that the sun was about 20 times as far as the moon. Actually, it is about 400 times. 400 times. Distance of the moon is, if you say 1, then distance to the sun is 400 times this. Although his figures were wrong, Aristarchus nevertheless did deduce from them that the sun must be at least 7 times larger than the earth, pointing out the illogic of supposing that the large sun circled the small earth. He decided that the earth must be revolving around the sun. He said that. Then, unfortunately, no one listened to him. Later astronomers, beginning with Hipparchus and ending with Claudius Ptolemy, worked out all the heavenly movements on the basis of a motionless earth at the center of the universe, with the moon 240,000 miles away and other objects an undetermined distance farther. This scheme held sway until 1543, when Nicholas Copernicus published his book, which returned to the viewpoint of Aristarchus and forever dethroned Earth's position as the center of the universe. And that completes this subheading. Early measurements. How interesting it is. Early measurements. You know, it is a distance. First they calculate the Earth's diameter and circumference. Then they calculate the relative size of the moon. Then they calculated to the sun. At least they came to had a fair idea that it was like quite a number of times than the moon, and that sun could not have circled Earth, but that was not accepted. Later it was accepted, but at that time it was not accepted. So this is a wonderful story. I look at history, including history of science, as an endless story, and each is an end in itself. Just for the fun of it, we can enjoy these endless stories, and each has a lot of lessons, directly and indirectly, and you can understand how your eyes are opened each time your eyes are open, and that's the beauty of knowing things, and that's why we're making these videos. Thank you.